Hello everyone, my name is Yuan. The topic of my paper is data-centered and usage-based security service. I will first present the context and the state of the art before explaining our usage-based data protection service, which relies on an information system meta model used to describe data assets, an extended usage rule manager defining precisely when how an information system can be used, and lastly, our usage governance manager controls the real usage on data assets. This distributed usage-based data protection is designed for a collaborative information system integrating smart IT, which leads to new security challenges. Traditional information systems are well-patronized systems, allowing to design and deploy an efficient control-centered protection, integrating social media and analytics to improve business, cloud-based deployment to improve costs and efficiency, or Internet of Things to support Industry 4.0. These information systems are turned into unpatronized systems involving collaboration among several parties. Last but not least, such distributed organization may also involve mobile networks technologies. This leads to define a multi-tenancy and often inconsistently protected information system with unknown limits. This context involves designing new protection models to fit this unpatronized environment. Sharing data with untrusted groups leads to multiple copies dispatched without control on usages and purpose. Communication means may include vulnerable networks. Moreover, mobile technologies use distributed data storage to bring data closer to consumers, but this may also lead to new risks as this distributed storage is hard to protect consistently. New risks are also due to analytics processes. Hidden data may be revealed using big data processes and data science. Cloud computing requires paying attention to virtualization protection and consistent protection among the different cloud nodes into consideration. To mitigate these smart IT risks, a data-centered protection strategy is needed to manage trust, usages, and a consistent protection of multiple copies, etc. Let's come back to the state of the art. Risk management should analyze the threats and vulnerabilities and their potential damages, taking into account these new smart IT usages. Integrating privacy preservation, risk management should expand usage description, paying attention to the information and process categories. Identifying fair usages relies also on these process categories so that more precise consent can be set. As required by the GDPR, focusing on the data consumer side, they have to prove their fair usages and consents. To this end, Fieldworks have introduced the blockchain technology to store consents and provide access keys to data. Despite this rich background, few questions remain to provide a consistent protection on data distributed among different information systems. First, data may be shared and replicated in different information systems, leading to inconsistent protection. To overcome these limits, we propose an information system meta model to describe data assets, their copies, and the services using them. Of course, protecting assets depends on the way the information is used. So how can we identify precisely usages? We also have to take advantage of the business process description to provide a better control on usage rights allegation. This requires providing a unified ontology to describe usages and protection goals. Third, as we address distributed organizations, we have to pay attention on protection governance, proving consents and controlling the way data assets are used. To fit this requirement, we propose a blockchain-based implementation of our usage governance management. Focusing on the asset protection consistency, we propose a unified information system meta model, including 3 parts, describing the organization, the logical description of both data assets and of the processes using them, and the physical copies of the data assets and the web service processing them. This meta model provides a unified version on the multiple replicated data assets split among different information systems. This model also allows defining usages on assets. Each business process and associated business task are defined precisely using logical asset pattern to describe semantically the data they use. Running business process will provide a dynamic description of the way assets are used. To this end, logical assets are connected to the logical asset pattern. This allows keeping a unified version on the multiple replicated assets split among different information systems. Obviously, asset protection means paying attention to the way security means are deployed and on the way assets are used. By integrating business and technology operations can be defined precisely. To this end, we have designed a usage ontology, extending the traditional usage and protection ontology with more precise usage information such as business area, the process motivations, and the process control purpose, and also the physical execution part. Meanwhile, the data-related operation defines the generic usage consequence of a business service, logical operation, and its atomic operation precise the data-related operation in the task and execution. According to our meta model, we can define precisely assets requirements of protection to compare it with the protection proposed by different services using these assets. So we can define two kinds of protection policy: requirement protection defined by the data owner and the quality of protection defined by the data consumer. The quality of protection is defined formally for the logical asset pattern used by a business process or a business task. This is process and this is task. Both requirement of protection and quality of protection are compared to identify if the asset will be consistently protected. Moreover, the integration of the usage policy defines precisely the business motivation and purpose. Its usage and protection assertions are used to generate the terms of usage policy, defining precisely the way an asset will be used and protected. The terms of usage defines contextual protection with protection management. It considers the organizational collaborations, internal operation, and security service implementations. Our extended usage assertion model defines the assertion attributes, status, which defines linked assertions. The asset owner and the subject refer to the original or delegated status of owner and consumers. The object defines the asset for which the assertion is defined. The usage context refers to the usage management ontology we defined before, and the protection context refer to the protection ontology, including the protection goal, like this, and countermeasures context and countermeasure strategies. And also key management define the owner and consumer approving this assertion, taking advantage of the linked assertions. Here, we will give an example of the terms of usage assertions. Alice wants to buy Bob a gift. On online shopping platform, online shopping collaborates with company B to deliver the product ordered by Alice. For this process, two terms of usage are generated. One is between Alice and online shopping, the other is between online shopping and company B, while the terms of usage between online shopping and company B needs to refer to the terms of usage approved by Alice and online shopping. These assertions take advantage of our usage ontology to derive the data-related operation into more precise logical operations to provide a finer grained usage control. They then will be published and validated by our usage governance. This example has shown that usage assertions can be derived from an original consent, and that assertion may be linked. To this end, we will define a transaction derivation process starting from the business transaction associated to the business process refined into user transaction associated to the logical operations managed by the logical service, the business task, and finally into physical transactions to grant or deny data access operations by the physical executions. Focusing on the key management part, we will consider the different terms of usage interactions to define the asset owner and consumer status and their role according to the business service hierarchy. Although the terms of usage are stored in our metadata, we take advantage of the blockchain technology to ensure terms of usage immutably. We introduce a smart contract factory to generate the different smart contracts derived from these terms of usage assertions. The exchange smart contract considers the global usage authorizations in the organizational layers, while the usage smart contract implements authorizations with precise logical operation and process purpose, and the physical smart contract integrates system protections with environmental conditions, so it needs to consider transaction derivation from different terms of usage and smart contracts. To conclude, Our data-centered and usage-based security service will provide answers to three data protection challenges: how to manage the protection consistency, how to define clearly usages, and how to govern usages. Further works will focus on expanded tests. And thanks for your attention.